So I'm going to talk a little bit about, Hannah and I are going to talk a little bit about the pathologist job. It is just hot off the press. We've got the opening party tomorrow night. The client has moved in. I'm going to just give a little brief overview of the project and a little bit about the client, and then Hannah's going to get into the detail of the project. But needless to say, yeah, we're very excited. It's just across the line, and hopefully you'll agree that the concrete is the star of the show for the project. So the client is a client that we've known for about 30 years. We worked on their original building, a relatively young college by comparison to some of the other medical colleges, such as physicians. They keep telling me they're very keen that we stress that pathology is not all about dead bodies. Of the 11,000 members, only around 70 or so are forensic pathologists. Most of their work is in hospitals dealing with living patients, and pathology is actually the study of diseases, which most of you probably know, but he asked me to tell you that every time I give a presentation. So this building will form the administrative headquarters for the organisation, so there's no dead bodies present, and hopefully very few diseases. So their original home, so it was a bit of a tough ask in that they were based in 2 Carlton House Terrace, which is a Grade 1 listed Nash building. It was hugely popular with the staff and obviously a gorgeous building, so a bit of a tough ask to follow that. But whilst it was beautiful, there was a couple of things that weren't quite right for the client. It was highly cellular, so a lot of the staff felt as if they worked in silos and didn't get to meet each other. And also there was a very solid front door as you get to these sort of old buildings, and they wanted a much more transparent view so that members of the public can see and feel much more welcome to go into the college. So they set about selling their lease, which was a short lease left with Crown Estates, and to look for a freehold. And they made the possibly brave decision to leave Carlton House Terrace and move east to Ailey Street, to sort of Whitechapel, Aldgate area. And this is what your money buys you, from selling a lease on the Mall to buying a place in Aldgate. It is a typical 80s building, an infill site, and not particularly attractive, but our initial thoughts were, as some of our previous speakers alluded to, is to try and reuse the building, maybe change the facades. But they're not a developer, so they only wanted to do this building really once, and our brief really was that for the next 100 years, picking up on your comment about this frame, this building's to provide the flexibility for them to grow into. They've got expansion plans, and how they work now is probably going to be very different to how they work in a few years' time. So, and one of the key parts of the brief was also to provide a 200-seat flat floor auditorium. So, looking at the existing structure, we just couldn't really get that to stack up without significantly compromising the building. So, the decision was made to take the existing frame down, but we have reused quite a considerable raft foundation, which Hannah will talk about more, and that decision led to a lot of the decisions on the design of the structure of the building. So we said about writing a brief, a little glimpse of what the final building looks like, and there's some more photographs at the end, but I won't talk too much about this because we're going to obviously try and get onto the concrete as soon as possible. But the brief is really for a hybrid building. And we're calling it it's a new generation of knowledge buildings, really. So it contains a flexible hybrid of workspace, social and educational functions, but then it's designed in a way that those interact, so people are likely to meet each other from different disciplines. And so it's effectively a number of relatively standard floor slabs, of which we then carve into to create voids and circulation spaces to encourage these meeting places and encourage areas of interaction. The floor plates themselves are relatively simple, probably looking at the 5th floor plan there, which is a typical floor. You can see there's not much in the way of columns. It's big open plan space with a core just to one side, and then that's the diagram throughout the whole of the building, and then that can be fitted out in a number of ways to suit the various uses. But in 10, 15 years' time, 20 years' time, that can be reconfigured very easily. None of that's structural, it's just that basically the 5th floor level shows the structural diagram. And then just a little bit on the facades. It's an infill site, so the 2 facades are really made up of the same materials, the same components, but whereas the front north-facing elevation is more restrained to provide that sort of entrance and sort of give the college the gravitas it wanted for that status of a Royal College. The south elevation allowed itself to be a little bit more playful. It's south-facing, so it was a deeper facade, and it responded to the not only trying to reduce the amount of sun onto the glass in the mornings to give the passive M&E systems more of a chance of working and the thermal mass, but also to capture certain views and respond to that context of the rear of the site. And then finally, just before I hand over to Hannah, I mean, as you'll see, concrete really is the star of the show, but a number of other materials really is the brick that was used as a cladding material and then taken into the building in the more communal public areas. Wax mild steel was used for the circulation routes and the stairs, and then timber panel was really a nod to their previous building, where we used timber walnut in this example, just to sort of accentuate some of the key spaces and the more important spaces that were all timber lined. So I'm going to hand over to Hannah now to talk about some of the detail.
Great. Hello, can everyone hear me? So focusing in really on the concrete then, I suppose there are two elements that we will discuss. We've exposed all of the thermal mass within the building. All of the vertical elements of the concrete of that thermal mass have a board marked finished, and the horizontal elements all have the coffered slab that you've seen in some of the earlier photographs. So before going into the detail and the environmental efficiencies that we have achieved with that, I thought it would be useful just to say a couple of things about achieving a visual concrete finish. So there are wonderful tools available to design teams now to achieve the level of coordination that is required for a project like this. These are some screenshots of the BIM model that we were using. So on the far left-hand side you have the structural model, in the middle you have the MEP, and on the right-hand side is the architectural model. So BIM has a kind of wonderful ability that I suppose no one can hide. You have to coordinate it all much earlier on in the process, and I think that is a huge benefit in achieving a good visual concrete finish. That is also backed up in our process with what people would perceive as a more traditional approach to design in card models, one-to-one mock-ups. So it's about early coordination and early contractor engagement, but it's also about really getting into the nitty-gritty of the detail early on in the design process. A lot of joined-up thinking as well. So we had our structural engineers, Watermans, working on the project, and they produced their NSCS specification for the concrete, but this was also backed up with a separate visual concrete specification from ourselves at Bennett's Associates. It was important that those two documents really kind of reference each other and work together, and the visual concrete specification included a lot of photographs within it as well. I think people often think that specifications have to be very kind of dry, wordy documents, but actually putting photographs into those specifications really helps in defining what is and isn't acceptable in terms of a concrete finish. So, as our earlier speakers have illustrated, there's a very kind of quick, easy gain that you can achieve in the concrete mix in terms of embodied carbon. And with this project, there were two options available to us, pulverized fuel ash and GGBS, ground granulated blast furnace slag. And we opted for GGBS on this project. One of the reasons driving with that was actually that the GGBS makes the concrete appearance much lighter, whereas PFA makes it a lot darker. And we realised early on in the design process that we wanted to make the concrete as light as possible so that we could use the light reflectance off that soffit to improve the quality of the spaces internally. So that's the embodied carbon of the concrete. And now I'll move on to the thermal mass and the efficiencies that we were achieving in the structural form. So the image on the left-hand side is illustrating how that thermal mass is working. So centrally cooled and heated air is pumped through the floor. Through natural convection, as it rises through the space, it's extracted at high level, and that's pulled across the concrete soffit and using that thermal mass. We're also using the coffered shape of the concrete soffit almost like entire light fittings as well, rather than just having spots. So we're uplighting the concrete as well as having direct task lighting. This is a very early stage structural diagram from Waterman's, and we established a 1.2 metre grid that worked quite neatly across the site. There was a real drive to minimise the number of columns within the building, bearing in mind the issues with the existing building that was on the site. So we managed to achieve a highly efficient core design that was using fin columns and limited the number of columns within the floor plate to 2. So within that coffer design, I think when you get into that level of detail, there are real efficiencies that you can start to achieve. And we went through an iterative process examining 2 things. One, how we could increase the surface area of the concrete as much as possible. And secondly, how we could reduce the amount of concrete being used as much as possible, both for the environmental efficiency within that, but also because we didn't want to overload the existing basement slab that we were reusing. So this diagram here is looking at that iterative process of examining the surface area. In terms of the concrete within a building, it's actually only the first 100 millimetres of concrete that are having any effect on doing that kind of thermal mass job on affecting the air temperature. So on a typical 300, 350 mil slab, you've potentially got 200 mil of concrete that isn't doing anything thermally. So by going to the coffered concrete slab, we're reducing the top of the slab down and increasing the surface area at the same time. This was the same kind of study that we were doing again for the volume of concrete being used. Interestingly, we found that actually both in terms of the volume studies that were being done and the surface area, it seemed to be that a 10-degree angle on the coffered slab was coming out as the sweet point, really, in terms of achieving the greatest efficiencies. So this is the finalised kind of coordinated structural diagram, as it were, of that rib coffer. You can see that the top slab we've got down to 125 mil, so really efficient in terms of material, and then you've got a 425 mil rib below that. And then again, through that process, looking at the lighting and how that can be integrated within that. And then this is an image of what we've achieved on site. So you can see that we're achieving something that's highly environmentally efficient, but I think from our perspective, it's particularly interesting because it's creating spaces of really strong architectural character as well. And then, of course, there's all the environmental benefit of emitting all of the ceilings and all of the plasterboard linings as well on top of that. So before I go into some final photographs of the finished spaces, I was going to quickly illustrate to you how we've achieved this on site. The coffered concrete slabs have been achieved using GRP moulds. We looked early on in the process at whether or not we could use expanded polystyrene formwork, but actually found that we couldn't get the bespoke shapes that we required, and you end up with a lot more seams in the concrete. And GRP is incredibly resilient, and you can reuse it a number of times. This, I think, was Jenny. You had this slide as well earlier on. These are the GRP moulds being installed on site, and I think it's also worth saying that we're not using a kind of special whizzy mix of concrete here. It's standard stuff. It's got the 30% GGBS, but it's not a self-compacting mix. And so, in order to achieve that really good visual concrete finish, the stress then is on the workmanship on site and getting that formwork right. So it's sealing all of the joints between the moulds, and we had a fantastic contractor involved, Gilbert Ash, and their subcontractor Oliver Connells, that managed to achieve that for us. And of course, it's also to do with the placement of that concrete on site as well, making sure that it's properly placed and properly pokered and vibrated into all of the nooks and crannies so that you don't end up with aggregate bridging and lots of air holes. This is that process on site viewed from above. So you can see the GRP moulds on the left-hand side being installed. We were looking at 4 to 5 weeks with a turnaround per floor, and the concrete contractor had ordered, I think it was 1.5 floors worth of GRP moulds, so that allowed them with the sequencing of the works. And I think they'd over-ordered as well because they were concerned that maybe the moulds would be damaged, but we found that by the time we got to the 7th floor, actually you could probably have done another 7 floors with the same moulds again, so it's an incredibly resilient, reusable mould. And then these are just a few photographs of those spaces before the finishes were started to fit out, so you really get a sense of that, of the skeleton of the building and getting that structure right and allowing all of the other moves within that to work flexibly. And if you're an impatient architect, it's fantastic because you get a sense of what the spaces are going to look and feel like far earlier on in the process on site. So there was really very minimal repair work required on site, a few kind of specialist repairs to joints and things, but that was it. And I'll just finish with a few photographs of the finished spaces. So this is the view that you have when you first walk into the building. You can see it's very light and open and airy, and actually that coffered concrete soffit really helps to lead your eye right into the heart of the building. So going back to what Rob was saying earlier about wanting to dispel this myth that pathology is just about dead people, it was all about that kind of public engagement and pulling people in, and the structure is helping to do that. This is a photograph of the first floor foyer space before you move into the 200-seat auditorium. We're achieving really kind of wide spans at this point, column-free, and you can see the introduction of that other palette of materials of walnut and steel works really well with that light concrete. This is the 200-seat auditorium space itself. On the right-hand side, you can see those fin columns that Rob mentioned earlier on the south facade, controlling the natural daylight gains into that space. The timber panelling that runs throughout on the walls is perforated and has an acoustic mineral wool behind it to improve the speech intelligibility within that space where that's key. And I suppose the only other thing to point out in terms of thermal mass and the performance of this space, where we've got potentially in this space 200 people turning up in one go, the thermal mass of the concrete is helped by the addition of some passive chilled beams within the coffers to increase the responsiveness of the thermal mass. Outside of that, where we've got the standard office spaces and foyer spaces, there's no chill beams at all. The thermal mass of the concrete is responsive enough on its own. And then this is a photograph of the office atrium space. There's another space where we'd carved out some of the structure to pull natural daylight into the deep plan office space. And a few photographs of boardmark concrete. We've just put them in there because we're really proud of it. And this image, I think, kind of summarizes quite well how you've got that whole palette of materials coming together. You've got a really rigorous, environmentally efficient structural concrete frame with really efficient fin columns and an efficient exposed soffit, and then a clear hierarchy. That's the kind of enduring element within this. And then the more sort of ephemeral elements within that of the timber and the brick and the metal staircases feel robust but can be changed in the future and ensure the long-term viability of this building for the college going forward. So I think that finishes there. So if any questions, thank you.